to penalize you 100% if you just make a calculator error. I want that to be the trivial part of any deduction if there is one. So show me your work, please. Let's go on to example number 3. So if I read number 3, let's stop ourselves and record any info that's relevant to these variables in the different equation. A car slows down from 30 meters per second, stop. Slows from a beginning speed, so call that initial velocity of 30 meters per second. It slows down from that initial speed to some speed later of 10 meters per second. We don't care if it keeps slowing down more. This just says it does that. It has an acceleration of 4 meters per second, which is the same thing as, I'll write it here to save some space in the middle, 4 meters per second squared. Either way you use that is fine. It doesn't really matter. It undergoes a displacement of 100 meters. So that's the delta x. And we need to know how much time it took. So that's what we want to find here. So back to that 3-step process. This was step 1. Step 2, use this list to figure out what equation will work for you. It's kind of nice in that you're given a lot to work with. If you know these other 4, there's only the one other variable that could be anywhere in these equations. So you really have a lot of choices. I would use the simplest one when it comes to algebra if it were me. We haven't used, well, we did use that one there. We could easily use that one again, where you plug in 30 for your initial, 10 for your final, and your time, and you can, and your 100 for your delta x, and you can solve it for t. Here's the sneaky part to this question. It's this acceleration. If you're moving in quote unquote the positive direction, which is implied by not saying anything by that, and you're slowing down, your acceleration is going to have a negative in front of it because it implies the direction is not helping, or the acceleration is not increasing your velocity, but it's reducing your velocity. So subtracting off 4 meters per second of speed for every second on the clock that ticks by. So that's a sneaky one. But let's go ahead and use one of the different equations than number 4 because we just used that one. How about, I don't like this one because I got these 2 speeds and it's going to lead to a, well, actually it just has that one, but it's going to turn into a quadratic equation problem, and that's not that fun. So let's see, which one should we go with? Let's go with number 3. No? Can I go with number 3? Is there a t in number 3? There's not a t in number 3, so that tells me I can't even use number 3. Why not this one? This one's easy again. You could use any one of 1, 2, or 4 because they have t's, and you have all the rest of the information that you would ever want to know to do this question. So I'm going to pick one that's easy. I'm going to say, let's do with number 1. So pick the equation that'll get you to your answer. Write it down for a point without any numbers in it yet. So V final is 10. Acceleration. Maybe this is a good one to pick because I can remind you, you have to put in -4 because you're slowing down in this case. And your time is what we want to figure out. Leave that there. And your initial speed, 30. So if I do the algebra, take away 30 first, minus 30, it gives me a minus 20 on the left, equals -4 times t. Divide both sides by -4. Those cancel. So this becomes +5, and it's a time. So seconds should be the unit. Notice how the 2 signs cancel each other out. The 2 negatives cancel each other out to leave us with positive. If you didn't catch when you were working on your own that this should be a -4 for the acceleration, you would have ended up dividing negative 20 by 4 and getting negative 5. And negative time doesn't make sense. Almost always when that happens, it's something with a sign, either in your algebra or you forgot your acceleration or something like that. That should be negative. So that's the answer to number 4. So a point for picking your equation, a point for plugging the numbers in the right spot, and a point for the number with the units for your final answer. If this was a test scenario. Example number 4, I'm going to erase this because we're going to need space for 2 problems here. If you need a break, pause, get up, walk around, do something to kind of refocus, because this one's maybe a little bit more challenging, and then come back when you're focused and ready to rock and roll. So example number 4, we'll start now. Aircraft carrier jet takes off from rest. That means the initial velocity is 0 at rest when it starts, so that means no speed to begin with. And to a takeoff speed, that's the final then. 77 meters per second. We see some miles per hour in there. The only reason miles per hour is in there in parentheses is so you've got a clue. You can relate. If your car was going 173 miles an hour, you'd be maybe a little nervous, but you got a feeling for that. But I just wanted to give you a comparison to what 77 meters per second represents. We don't use miles per hour here. Everything is going to be in those base units for the science, the metric system of meters per second. So ignore the miles per hour, ignore the feet with the distance. So the delta x, 93 meters. Well, it sounds like 100 meters-ish, so it's kind of like a football field in length, 370 feet. So it's a little over the length of a football field. So that's pretty short distance to go from 0 to 173 miles an hour. I don't know about you, but that sounds fun. Okay, so from rest to 77, a delta x of 93 meters, we have no info on time. What does that mean? That means you better not pick an equation that has a t in it. Is there, what do we want to solve for? We want to solve for the acceleration. Okay, so can we use number 1? No, because there's a t and I don't have something to put in. Can we use number 2? No, there's t's all over the place and I can't use that. Can we use number 3? Well, there's no t's. Are all the other boxes checked? V final, check. V initial, check. Acceleration, want to find it, so it needs to be in there. And delta x, check. So equation then, step 2, I'm going to say let's use V final squared equals V initial squared plus 2a times delta x. Those are all multiplied by each other. So if the final speed is 77, that means I got to square that. The initial speed was 0, so obviously that's going to be nothing. And 2 times the acceleration times the 93 meters for our delta x. Okay, so if I square that, shoot, I don't know what that number is because I don't have it written down on my paper. But I'll do some algebra before getting to that thing. So we can combine these two things. This becomes 186 times a if we multiply the 2 and the 93. And that would be equal to 77 squared. So if I divide that by 186 and divide that by 186, it gets rid of those two things. And I know that the final answer is supposed to be, rounded off anyways, 31.9 equals the acceleration. Now you don't get full credit for your answer unless you also put the units on, and acceleration units, like we said before, these would be in meters per second, and this would be meters, so there's some extra steps in there with the algebra, but if you remember back to the other one, the algebra with the units, we could either call that meters per second squared or meters per second, like I showed you at the beginning. The last example here then, calculate the time it'll take to reach that takeoff speed. So now we're going to go to this. So acceleration now being known, 31.9, and you can always round your answers off to the nearest tenth. That's totally fine with me. I'm not into sig figs and everything like there would be in chemistry because we're not mixing chemicals and trying to prevent an explosion or anything like that. So now we want to find the time. So we're calling this part B. So this was 4A and 4B. Now we want to know what the time is. All right, so if the time is the thing that we got to figure out, and we know all of these other things now are valid and useful, let's pick the easiest equation that has a t in it. When I say easiest, I mean the least amount of algebra. Could I do this one? I know 93 meters is my displacement. I know initial speed is 0, so that middle term is going to be 0 times the time is going to go away, a, and then square the t. That's not horrible. Could we do this one? Sure. We did that in an earlier problem. We cannot use this one because there's no t to find. So it gives you options. Because we have everything, we could use 1, 2, or number 3. And since we haven't used number 2 yet, let's use number 2 and say delta x equals v initial times t plus 1/2 a times t. Just the t is squared. So you might think of this like this. The t squared in parentheses. Do not multiply 1/2 times the acceleration, then times the time squared or anything in the problem. This one we're solving for the t, so you probably won't do that. But in the future, remember that square the time. I sometimes work them backwards. Square the time, then multiply by the a, and then divide by 2 or multiply by 1/2. But in this one, we're solving for t. So I'm going to fill in the numbers now. The next step would be 93 meters, 0 for the beginning velocity, times t. It's really just going to mean that term goes away because it's 0. And then 1/2, what did we say the acceleration was? 31.9. And then t squared. So we're going to do a little math here. That's like 32 divided by 2 would be 16. So it's really 15.9 t squared. So to do the algebra, I got 93 divided by 15.9, and that's going to be equal to t squared. So I've kind of like simplified stuff a little bit. Now we got to solve it for t, so we're going to do the square root. And when we do the square root of both sides, there should be an answer of about 2.4, and it's times, so that would be seconds. Always think about whether or not your answer makes sense too. 2 seconds for this jet to get down to the end of the runway to take off isn't ridiculously quick or ridiculously slow. So it feels like that probably is a reasonable answer. And we didn't talk about thinking about whether or not your answer seems reasonable, but I would always try to make sure that you look at an answer. If the time was 700 seconds or 0.0003 seconds, you might go, wait a minute, one of those sounds way too big or way too small, knowing that a minute is 60 seconds. So always think about whether or not your calculator is telling you something that seems to be a little bit funky for some reason, and let your intuition guide you. If it seems funky, then maybe you made an algebra mistake, maybe you made a decimal mistake, but stop and then relook at all your work and see if it looks like you can figure out why your number seems ridiculously big or small. And if you can't figure out that, then ask. I hope this was helpful. I'll link some more problems on another worksheet for tomorrow. But use this video and these examples maybe in the future if you get hung up. I hope it helped.